today's video. In this video, we are going to be discussing ways that we can solve triangles. So in this video, we are firstly going to talk about what right angle triangles are. Then we are also going to talk about ways that we can solve triangles, and one of those ways will be sum of angles in a triangle. We'll also talk about Pythagoras theorem, and we'll also talk about trigonometric ratios. Now this is a right-angled triangle, and we say it's right-angled because it has a right angle. This little square in the bottom represents a right angle rather, which then becomes a right angle triangle. Now this side, which is opposite to the right angle, will always be your hypotenuse in a right angled triangle. And because right now we are focusing on this yellow or gold highlighted angle, which is alpha, now this side, which is opposite, the side AB, it's opposite to the angle, and that is why in this case it is called the opposite side. And then of course the side that is next to, which is AC, will then be your adjacent side. So this is your adjacent side. Now of course if we change the angle of focus, so now we are focusing on theta. Now of course the hypotenuse will remain the same because it is the side that is opposite to AB. So this will be your hypotenuse. But then this side, which is AC, will now be your opposite side. Why? Because it is opposite to angle theta. And then the remaining side will be now your adjacent side. So this is important because it reminds you that you cannot just determine the opposite or the adjacent side. You firstly need to make sure that you are focusing on which angle. The angle of focus is very important in determining the opposite or the adjacent side. Now, of course, if you want to solve triangles, there are tools that you can use. So the first one is sum of angles in a triangle, and we use it for angles. And then we have Pythagoras that we use for sides. And finally, you have trig ratios that we use for moving between angles and sides. So let's look at each of these tools. So sum of angles in a triangle. So the first one, of course, is your right angle. Then you have your alpha, and then you have your theta. And then, of course, the rule that you might have learned about in grade 8, that is the sum of angles in a triangle will always add up to 180 degrees. But of course, in this form, you can't solve this equation because you have two unknowns. So the way that you solve this is if you are told, maybe let's say you were told that theta is 40 degrees. Because now the equation will be transformed and you will have only one unknown in this equation, which would be alpha. And then you can transpose everything. Let's go back. You can transpose everything, and then you will have 180 minus 90. So you'll have minus 90, and then you'll have minus 40 degrees. So alpha will finally be 50 degrees. Right. So if you move on, you have Pythagoras theorem. And we said Pythagoras is used for sides. So it says that the sum of the two other sides will be equal to the square of the hypotenuse. So the square of the two sides, if you add them, they'll give you the square of the hypotenuse. So AB squared plus AC squared will give you BC squared. So for an example, if you are told that this side, uh, if you're told that this side is 3 and this is 4, and then you were asked to find side BC, so what you will do is you will substitute AB, we said is 4, plus AC will be 3. So we're just working with what I just gave you, even though it looks like AB is much shorter than AC. So if you continue to simplify this, so this is AB squared, or what you can do is, so here you have 4 squared plus 3 squared. You can just add a square root on both sides, so that BC will end up being 5. So this is how you would use Pythagoras theorem to solve a side. And because it has 3 sides, you need to at least know 2 so that you can find the third side. Then if you move on to trig ratios, now we said trig ratios are useful when you are moving between sides and angles. So this is a neat way that you should learn, and that tells us about the relationship and the definition of trigonometric ratios. So the relationship between trig ratios and sides. So we say that will tell us that sine of an angle is equal to the opposite side over the hypotenuse side. If you talk about cos, then cos will be the adjacent side over the hypotenuse side. And then tan will be the opposite side over the adjacent side. So if you take this into triangles, you can see how this could be applied to triangles. So we are saying that sine theta, which we said is opposite, so this is the opposite side, which is AC, as you can see here. And then over the hypotenuse side, that is opposite to the right angle, which is BC. And you can do the same for the other two trig ratios. Then in this particular diagram, you are changing the angle of focus. So now we are focusing on alpha. So this would be the opposite side, as you can see here, over the hypotenuse side, which is BC, and the rest can be found the same way. Now let us look at an example. So in this particular example, you are given a right-angled triangle. We are confident that this is a right-angled triangle because we can see the right angle there at the bottom. Now, we are interested in finding the value of A. So to find the value of A, we have to first determine if A is an angle or a side. As you can clearly see from the diagram that A is representing a side. And we learned that out of our three tools, if you are looking for a side, you need to use Pythagoras theorem. But the issue is that we also do not know the hypotenuse. So there are two unknowns, and hence we can't use Pythagoras theorem. Out of all the tools that we have, the tool that we can use is trig ratios, because trig ratios will allow us to take advantage of the angle given and also the side given. So this is how. Tan 60, tan, remember, from to a, so it's opposite, because A is opposite to the angle, over the adjacent side. So it's A over 4. Then you multiply by 4 on both sides. So then you get that A is equal to 4 root 3. So if you put in your calculator 4 times 60, you get 4 root 3, or 6.93 centimeters. In this particular example, we will look at a much more detailed and interesting diagram. So in this particular diagram, you are given that CD is perpendicular to AB. Now sometimes other students are confused by this. So the right angle is only written on one side. But we know that on this side as well, we should also have a right angle. And the reason is that, remember, in Euclidean geometry, we learned that the sum of angles on a straight line is 180. And if this side is 90, the other side should also be 90. Right, so let us look at the questions. So the first question is saying we should calculate the size of angle BCD. So BCD. So this is the angle. This is the angle that we are talking about. This is our BCD, marked in red. So this angle, if you add 40 degrees and 90 degrees, you should be able to get the missing angle, which I've just indicated with a cross or X. Now, if you're talking about angles, we learned about one tool that we can use when we want angles, and that is sum of angles in a triangle. So we can say that CBD plus BDC plus BCD is equal to 180. And of course, we know the two other angles, that is 40 degrees for CBD and 90 degrees for BDC, which leaves the only unknown to be BCD. And then we can transpose or subtract on both sides 90 degrees and 40 degrees. So we get that BCD is 50 degrees. Then the second question says, calculate the length of CD. Now CD is the side, and this is the side that we are interested in finding out. Now I always advise students to always use the given information. And remember, this is the given information. So yes, of course, in the diagram we've added 50 that we found in the previous question, but just in case you were incorrect in the previous question, it's much safer to use the given information. In that case, let us see how we can use this information we have. So in relation to the angle, CD is opposite, and in relation to this angle, 16 is adjacent. So then we can use trig ratios and say tan 40 degrees is CD over 16. We multiply on both sides by 16. So this will be our solution, 13.43 centimeters. So just to conclude, and remind ourselves of what we've gone through. So we've talked about solving triangles, and we did specify that we had three possibilities whenever we wanted to solve triangles. The first one was sum of angles in a triangle, which we said those angles will add up to 180 degrees. We also had Pythagoras theorem, and then we also spoke about trig ratios that we can remind ourselves easily using SOHCAHTOA. And we also did specify that sum of angles is used to solve angles, Pythagoras is for sides, and trig ratios is used to move between sides and angles.